So now we want to know, given that we observed 5 heads, what is the probability we picked the two-sided coin? Written in probability notation, what is the probability of getting the two-sided coin given that we observe we got 5 out of 5 heads? So remember, the hypothesis is always A. What you observe is B. So Bayes' rule states that the probability of A given B is equal to the probability of B given A times the probability of A, all divided by the probability of B. Now this seems really abstract, but let's take this apart. Don't give up on me. Let's look at what this looks. What is the probability of B given A? Well, if it says, what is the probability of getting 5 out of 5 heads given that we pick the two-sided coin? Well, we know that that's 1. If we pick the two-sided coin, you're always going to get 5 out of 5 heads. So that part of the equation is easy. Now, what is the probability of A? The probability of A was the probability of picking the two-sided coin. Well, we know what that is. That was 1 out of 10. Now we have to figure out the probability of B, and that's a little harder. What is the probability of getting 5 out of 5 heads no matter which coin we picked? Well, we figured that out, remember? Initially, we figured out what the probability of getting 5 heads was no matter which coin we picked. So if we pick the normal coin, we know that the probability of getting 5 out of 5 heads was 9 over 320. If we picked the two-sided coin, we know that the probability was 1 out of 10. So we combine those two. Combined, the probability of getting 5 out of 5 heads overall was 41 out of 320. So now we take that number, that's the probability of B, the probability of getting 5 out of 5 heads no matter which coin we picked. And now we can actually plug these values into Bayes' formula and find out the probability of picking the two-sided coin. The probability of B given A was 1, the probability of A was 1/10, and the probability of B is 41 over 320. You don't need differential calculus to figure this out. This is simply 4th grade fractions. So doing the math, you can see the probability of actually picking the two-sided coin, given that we observed 5 out of 5 heads, is about 75% chance. So if you had to bet, this is the smartest bet that you can make. It's not just a random guess, it's the smartest guess. Our patients depend upon us in making informed guesses, not just random guesses, but the smartest guess that we can possibly make.